In Egyptian mythology, Ra stands on the primordial pyramid and masturbates, and from his semen creates all life. In other cultures, it's an earth mother, a goddess who brings life into being. Every culture has its story. A rainbow serpent, a god creating man out of dust. It's perhaps the biggest of the big questions, the origins of life. Now science has its own genesis, but is it any more credible than the ancient mythologies? Paul Davies, in this program you'll be cross-examined about the origins of life. We'll leave the why to the theologians, but I want to ask you about the when and where. Can science ever really tell us how life began?
First, I'd like to say that the scientific attempt to explain the origin of life proceeds from the assumption that whatever it was that happened was a natural process. No miracles, no supernatural intervention. Ordinary atoms doing extraordinary things to bring life into existence. So we have to start with that assumption. The problem is that it may well be that life on Earth was a unique event, perhaps unique in the entire universe, perhaps unique on Earth. If it only happened once, then science has a lot of difficulty in reconstructing the precise details, because it's not just a matter of chemistry, geology, astronomy, and so on. It's also a matter of history. There may have been a unique historical sequence of processes that went on that simply cannot or could not be reproduced elsewhere.
But given scientific hubris, that's not going to stop science, is it?
And that's exactly right. I think we sort of feel that even if we don't know the precise details of what happened, we could at least work out the general direction. We could work out whether the origin of life is something that is quite likely under favourable circumstances or extremely unlikely. That's really the question we'd like to answer, because the issue as to whether we are alone in the universe or whether it's teeming with life hinges on how easy it is for life to emerge given suitable conditions.
Is there anything in the genetic record which suggests any sort of life force?
The notion of the life force, I think, is utterly discredited. It's a very unhelpful notion. It's a very ancient notion, I might say. It goes back to Plato. Plato had the idea that everything has a sort of spirit or soul that animates it. And then in the Middle Ages, I think it was associated with, often with blood. People talk about the lifeblood or the breath. This something comes from the Bible, the idea that, breathing life into something. And then it got a bit more scientific when electricity was discovered. That seemed a sort of mysterious thing, and so maybe that was associated with the life force. Remember Volta's experiments with the frog's legs, made the legs twitch. You could almost believe it was bringing them alive again, you see. And Mary Shelley's Frankenstein, a great bolt of electricity, brought the thing to life. And then, of course, we discovered that electricity was a pretty straightforward type of thing, and so ideas moved on. The ether, phlogiston, these have all been associated with life. Even radioactivity. There was a time when people thought that if you irradiate something with radium, you might bring it to life. Well, all of these ideas have been completely discredited. They're not helpful anyway, because if all the life force does is explain life, then it's a sort of circular argument. The life force only manifests itself in a living thing. It doesn't explain anything. And so I don't think we need the life force. When you look at living organisms at the level of individual atoms and molecules, what you find is they're obeying perfectly ordinary laws, perfectly ordinary chemistry, perfectly ordinary forces involved. We don't need anything else, any extra ingredient.
It might be useful to put this into a time scale. So when does the whole process begin? What, 4 billion years ago?
Of course, we don't know exactly when life began, but there are fossils right here in Australia that have been dated at 3.5 billion years. Well, the Earth itself is 4.5 billion years old, so it's going back a fair way. But there is a hint of life even earlier than this in rocks from Greenland, which suggests that life may have been at work 3.8 billion years ago.
What do you mean, a hint of life?
Well, life does more than just leave fossils in rocks. It can change the chemistry of the rocks. And in particular, if you look at the carbon trapped in these rocks from Greenland and the isotopes of carbon, there's a suggestion that these isotopes have been changed in their abundances, and one possibility is that life did that.
Can you tell us about the heavy bombardment, so-called, because it seems to coincide with the fossil record of life?
Astronomers think that the solar system began when a large cloud of hydrogen gas shrunk under its own weight, and at the centre formed the glowing mass which eventually became the sun, and this was surrounded by a disk of swirling debris, gas and dust, which aggregated to form the planets, and the Earth was one of these. But of course it didn't happen overnight, it was an extended process, and in particular a lot of the debris that was lying around hit the newly formed planets, sometimes with great violence. Indeed, it's true that even today rocks crash into the Earth from time to time, we call them meteorites. But in the early days this would have been a very intense bombardment. You only need to look at the moon, it's pockmarked with craters, millions of craters, and this is the record of this early bombardment phase.
But it's not just holes, of course, is it? It's new material that then patinates the planet.
That's exactly right, that the early Earth was accreting, accumulating material from comets and asteroids and objects farther out in the solar system that brought to the Earth some of the raw material that eventually was to be incorporated into the biosphere, into life.
This would seem incredibly hostile time for life to be beginning during such a bombardment.
It wouldn't be too good to be around when you've got huge objects, maybe up to 100 kilometres across, crashing down out of the sky. If the Earth today was hit by a 10-kilometre sized object, it would almost certainly destroy the majority of species on the planet. And this does happen from time to time, I should say. Every 10 to 100 million years or so, the Earth takes a hit.
Have you got the time on you at the moment?
We don't know when it's going to happen. It's a random process. But during the first 700 million years of the Earth's history, this bombardment would have been much more intense. And the effect of the impact by a very large object, say 100 kilometres across, is quite awesome. The object itself would be mainly vaporized and would displace the Earth's atmosphere, vaporize its oceans, and create a rock vapor atmosphere that would have enveloped the Earth and glowed at a temperature of about 3,000 degrees, thoroughly sterilizing the surface. So if there had been any life on the Earth's surface prior to about 3.8 billion years ago, it wouldn't have lasted very long after one of these impacts.
So, Paul, we have a hint of life prior to the bombardment, the fossil record suggesting a certain synchronicity with the bombardment. Either way, life seems to be getting underway fairly rapidly.
Yes, it is something of a paradox that life got started so soon after this heavy bombardment ceased, and it suggests either that life forms pretty quickly under favourable circumstances, or that it came to Earth from outer space.
Now, we've just compressed the best part of 4 billion years into a couple of minutes. We've dealt with when, let's now look at where. Fred Hoyle used to argue that life might have been blown around the universe with comets. Is there any possibility, is it useful to even think about life being introduced in this way, or perhaps by being piggybacked on the Great Bombardment?
It's certainly true life could have come to Earth from somewhere else in the universe. That's entirely possible. However, it doesn't solve the problem of the origin of life. All it does is push it off into space. It was very fashionable in the 19th century to suppose that the universe didn't have an origin, and therefore why does life have to have an origin either? If life can jump from place to place, then we could imagine a universe in which life has always existed and the universe has always existed. And some people think, well, that somehow explains it, but you don't explain something by supposing it's always been there.
Is there not evidence within the genetic code of all life forms that there was a sort of Eden moment?
It's certainly the case that all known forms of life on Earth seem to have had a single common ancestor. There was a universal ancestor, not just for you and me, but for the mushrooms out on the lawn and the kangaroos hopping about in the bush, and even bacteria. We all seem to go back to a single common ancestor. Now, of course, it was Darwin's idea to have the metaphor of the tree of life.
That's what you were sketching there.
Yes, which begins here, you see, with a trunk. That would be like the first living thing, and this branches and rebranches and branches and branches again. And this is representing today, and these are all the surviving species of organisms. And if you start at any branch today and trace it back, you get all the way down to the trunk. Now, there will always be an earliest point of convergence where all existing living things have a common ancestor.
But that's different from the origin of life
That's
itself.
Right. A lot of people get confused by this. The last common ancestor is not the same as the first living thing, and almost certainly the last common ancestor was much, much more complex than the first living thing. We know that because all life forms on Earth are already immensely complicated. And if you look at the cells of all living things, they have very complicated structures inside them. They've got nucleic acids, which are themselves very complicated. They have little machines called ribosomes that make proteins. All of these things are the products of a lot of evolution, and yet they're common to living things here on Earth. And incidentally, we all share the same genetic code. That's perhaps the most powerful evidence for the existence of a common ancestor.
But it doesn't demonstrate that there might have been, to borrow a famous word from another sphere, a singularity. In other words, one place and moment in time when life begins. It could have begun simultaneously all over the planet.
Well, if it began like that in many different places at once, we would expect to find many different life forms with different chemical structures, different logical systems. But instead, everything that we study shares this common structure, this common chemical system, this common genetic code. And so this suggests that if life did spring into existence many times on the surface of the Earth, only one lot survived. And there's a lot of discussion as to why that might have been. If life is easy to form, you would expect it to form many times over. What has happened to all these other life forms?
Well, what happened in the 50s in the laboratory when a couple of scientists attempted to replicate what they imagined were the primordial conditions?
Well, one way you can try to find out how life began is to try to simulate the conditions that the early Earth would have been like. And this was done at a famous experiment in Chicago. Harold Urey and his student Stanley Miller took some methane and ammonia and hydrogen, gases that they believed would have been part of the Earth's early atmosphere, put them in a flask with some water, sparked electricity through it for a week or so. And they were delighted to find that the water went a sort of reddish-brown colour. And when they analysed it, they found that it contained amino acids. Now, amino acids are very basic chemicals. They're the building blocks of proteins. Proteins are, of course, absolutely crucial to life. So they felt that this was a wonderful first step to creating life in a test tube. If after a week you've made the building blocks of proteins, maybe after a year you'd make something more elaborate, and maybe after 1,000,000 years you might make a genuine living thing. Something might actually crawl out of this red-brown soup.
Were they able to play God in the laboratory?
I think in the intervening years the significance of this experiment has been re-evaluated. First of all, I should point out that the Earth's early atmosphere almost certainly didn't contain the gases that they use. There's a bit of a problem about that. But I think, more to the point, it's a mistake to suppose that there is a sort of road with life as its destination, along which a chemical mixture is inexorably driven by the passage of time. It isn't just a matter of carrying on doing more of the same, and the amino acids will assemble themselves into proteins, and the proteins will join up with nucleic acids and make a living thing. It isn't a one-way street like that. And the reason is very basic, that making amino acids is what a physicist would say it's thermodynamically downhill, which means it's a natural process which would occur like crystallization. It occurs automatically. It's favored by the laws of physics. But hooking the amino acids together to make proteins in these long chains goes the other way. That's an uphill process. It's a little bit like going for a walk in the countryside, coming across a pile of bricks and assuming that there'll be a house around the corner. There's a big difference between a pile of bricks and a house. Now, part of the problem here is that stitching or attaching the amino acids together to make proteins costs energy. Now, there was no lack of energy on the early Earth. The problem was how did this energy organize itself in such a way as to produce this extremely elaborate thing?
Okay, solve the problem for us.
Well, you see, some people say, you just throw energy at it and it will happen spontaneously. Well, it's a little bit like saying, put a stick of dynamite under the pile of bricks, bang, you've got a house. Of course, you won't have a house, you'll just have a mess. And the difficulty in trying to explain the origin of life is trying to explain how the elaborate organizational structure of these complex molecules came into existence spontaneously.
Does this suggest lots of sticks of dynamite under lots of piles of bricks?
Now, that's one game you can play. You can say if you do it often enough, on enough planets, and you wait long enough, sooner or later, just by chance, the right molecular combination will occur. Well, then you put the numbers in, and you find, to your absolute horror, that you wait almost forever just to get a single protein. The chances of just shuffling amino acids at random into a single short protein are 1 in 10 to the power 130. That's 1 followed by 130 zeros.
Paul, I'm getting very depressed by this because it sounds like life is never going to happen.
Well, if you're
For
going
heaven's
to
sake, do something.
if you're going to do it just by random shuffling, you would wait almost forever. So I don't think that's the answer. You see, people often say to me, particularly when I give public lectures and talk about the universe and all the stars and planets and so on, they say, the universe is so vast, there are so many stars out there, so many planets, it would be absurd to suppose that we're alone. There must be life on some of them out there somewhere. But when you look at the numbers we've just been talking about, it's simply not true. It's a logical fallacy to suppose just because you've got a huge number of planets, you're necessarily going to produce life somewhere. The total number of planets that are likely to exist within our observable universe is 1 followed by 20 zeros. Well, we were just talking about 1 followed by 130 zeros for a single protein. So it clearly isn't going to help just by extending the space to the observable universe. The odds against making life by some sort of random molecular shuffling are infinitesimal. So that wasn't how it happened.
Well, if something doesn't happen soon, we're going to dematerialise.
Well, there are other ways of approaching this, and one possibility is that life is somehow written into the basic laws of the universe. That is, that the laws of the universe have been rigged in favour of producing certain types of complex structures that are biologically relevant. In other words, you put all this stuff into a chemical mix, a soup if you like, and you let it do its stuff. All these molecules are milling around, producing lots of different reactions. But somehow, the laws of chemistry favour the production of just those things that you and I need for life. In other words, life is brought into being because things like proteins form much more favourably than other stuff.
Well, that would
So there's a
suggest that
bias.
life would not only spontaneously combust around the planet, but around the universe.
Yes, it would happen almost everywhere that you look for it. A lot of people believe this, but I think it implies a sort of cosmic conspiracy of gigantic proportions, because it means that the underlying laws of physics and chemistry somehow know about something as complex as a life form.
Well, that sounds like the
living cell.
life force. It sounds almost like the Platonic notion.
It does sound very mystical. It sounds like that somewhere deep down in the basic workings of the universe, life is written. Now, the problem for a physicist is that the laws of physics, indeed the laws of chemistry which follow from them, are simple and mathematical and general. Life is complex, non-mathematical, and very, very specific. And the difficulty is to understand how can life follow in a law-like way from primordial soup with this sort of reliability and dependability. I don't think that is the answer either. The third possibility is that life arises as a result of what is often called self-organization. That is to say that under certain circumstances, matter and energy have an uncanny ability to organize themselves into more and more complex structures, not directed towards life, not with life as a goal, as an end product.
Not a canny ability,
No,
in other words.
No, but the increase in complexity is something which can be quite surprising. And we see this in many areas. You don't have to look at living organisms to see complexity. We can see examples of complexity all around us.
In crystals, for example.
Take a snowflake. A snowflake is an ordered complex pattern. And there's no gene for a snowflake. There's no mystical force. There's no snowflake written into the laws of physics. And yet snowflakes form and can become very elaborate. So we see examples where physical forces and laws conspire to produce elaborate, organized, complex systems. And we might suppose that in the right conditions, there will be a sort of hierarchy of complexity, a bootstrapping effect where chemicals organize themselves to form one level of complexity and then the next and then the next and so on. And it goes on and on and on until something truly living emerges. But I mean, all of this, I mean, I'm waving my hands, and the answer is because it is a very ham-wavy argument. The truth of the matter is we absolutely don't know. We don't know how life began. I think we know where and when, but we don't know how.
But they presuppose, therefore, some sort of information system.
I think that's the essential point. It's not what we're made of, it's the information content, the software, if you like. It's the distinction that computer users use between hardware and software. It's the software that makes us living, the biological information contained in us.
But you reject the notion of that software being a life force.
Absolutely. It's got some elements of the life force in as much as it's immaterial. You know, software information by its very nature is something which can be encoded in hardware, but itself has a sort of independent existence. So it's got that immaterial aspect to it, but otherwise it's really quite different, because we're not talking about a magical, mystical extra essence. We're talking about information content, and for me, the great mystery about the origin of life is where that biological information came from in the first place. It must have come from our environment, of course, but how did it concentrate, how did it accumulate in molecules to the extent that we would call them living?
Paul, I'm computer illiterate. I wonder if you could find another metaphor for the information system other than software, hardware.
Yeah, well, there's one that I like quite a lot, and that is comparing the operation of a kite, which is literally hardwired to the controller on the ground, with a radio-controlled plane that has an informational channel. And how does the plane do it? Well, you push and pull some levers, and this gets encoded into electromagnetic pulses, and that information sent up to the plane and decoded. The radio waves themselves don't push and pull the plane around. It merely harnesses other forces and liberates them to do the job for it. So the radio channel plays the role of an informational channel. Now, the key thing about life is that it's based on a deal struck between two very different classes of molecules: nucleic acids, which contain the genetic information but can't do much, and proteins, which are the real workers in biology. Now, the nucleic acids on their own are helpless. The proteins on their own are helpless.
This is chicken and egg stuff, isn't it?
This is chicken and egg, and the great mystery about the origin of life is which came first, chicken or egg? Was it nucleic acids or proteins? That's the traditional mystery. Well, I think the ultimate mystery of the origin of life is more, what was it that turned the kite into the radio-controlled plane? Because you see, however much you evolve a kite, it ain't going to be a radio-controlled plane. And the reason is that the notion of radio control with an informational channel is a totally different type of conceptual scheme from the kite. And so it's not just a matter of more of the same. It's something totally new. And I think that is the real ultimate mystery of the origin of life, is how did a system leap that gap from being mere hardware, like the hardwired kite, to being a software-mediated chicken and egg combination.
Is there any place on or in the Earth today which might be closer to what things were like at the beginning?
Well, in fact, it turns out that there is. If you go deep down under the ground or under the ocean, particularly close to volcanic vents, then you do indeed find a large amount of these sorts of gases like methane and hydrogen coming up out of the Earth's crust. And the extraordinary thing is that if you drill down into the crust, you find that there are organisms living deep down there even today. And they're making a living not out of sunlight or eating other organisms, but directly out of the chemicals and heat energy coming up out of the Earth. In other words, they're basically living off the rocks beneath our feet.
Could they have been, in effect, bomb shelters for the bombardment?
Well, many people think this. They think that during this time of heavy bombardment, where the surface of the Earth was sterilized, there would have been enormous heat, of course, pulses of heat traveling down perhaps a kilometer into the surface of the Earth. But anything that was deep down beneath that, if its comfort zone extended that far, would have been safe from this terrible bombardment. So maybe it is, we've been looking at the wrong place all this time, that life didn't begin on the surface of the Earth in a warm little pond. Maybe it began in the region that has traditionally been associated with hell, the sulphurous depths with intense temperatures, and life came to the surface only later when it was safe to put its head up, when this bombardment ceased. So this sort of suggests life began hot and deep and only later migrated to the surface. And there is some confirmation of that, that if you look at the organisms that now live deep under the ground or on the seabed in the dark near these ocean vents, you look at their genes, you can tell something about the way in which they have evolved over time. The least evolved organisms are those that live at very high temperatures and pressures in these pressure cooker conditions, these boiling vents. And so we can think of these as like living fossils left over from a time 3.5 billion years ago when the Earth was a very different sort of place.
And are they genetically connected to us?
Yes, they still share the same genetic code the same basic chemical structure. So it looks like when we study these organisms extracted from these hellish conditions, that we're looking at something very much like the common ancestor of you and I.
In the next episode, our big question is, are we alone? Are the conditions that permit life so rare, so fugitive, that we're doomed to cosmic solitude? Or does an observable universe of 100 billion suns guarantee us a multitude of neighbours?